Okay, Unit 7 Differentiation. And as you already know the basics, we can quickly discuss and move on. So the general formula is if we have y is equals to x raised to power n, when we differentiate it dy by dx, that is, we bring the power down and decrease 1 from the power. This is differentiation of this generic form. If the gradient is positive, it is increasing function. If it is negative, that is decreasing function. So question exercise 7a, question 1, find the value of x for which f of x is an increasing function, given that f of x equals this. So increasing function when the gradient is positive. So if I select the first one, that is 3x square plus 8x plus 2. This is the function f of x. So when I differentiate it, this becomes 2 3 times 6x and 8. Now if it is increasing function, gradient must be positive. So 6x plus 8 is greater than 0 for x greater than minus 8 by 6, which is minus 4 by 3. So for all values of x greater than minus 4 by 3, the function is increasing. Question number 2 says find the value of x for which f of x is decreasing function. So same concept, but the gradient should be negative. So x square minus 9x, if that's f of x, when we differentiate it, this becomes 2x minus 9, and 2x minus 9 should be less than 0. So 2x is less than 9 and x is less than 4.5. So for values less than 4.5, the function is decreasing function. Question 3 says show that the function f of x is equals to 4 minus x bracket 2x square plus 3 is decreasing for all real values of x. So I'm simplifying this function. F of x is equals to 4 minus 2x cube minus 3x. Now we differentiate. So f dash x is equals to, this is constant, it goes away, that is 0. So minus 6x square minus 3. Now it said that show that it is decreasing for all values of x. So we see that if we plug in any value of x in this place, the square is going to make it positive, but this negative 6 is going to make it negative overall, and minus 3. So whatever value of x we use, we are always getting a negative answer. So we say that f dash x is less than 0 for x belongs to real value, and hence it is a decreasing function at all times. Question number 4a. Given that the function f of x is equals to x square plus px is increasing on the interval from minus 1 to 1, find one possible value of p. Okay, so f of x is equals to x square plus px. So f dash x is equals to 2x plus p, and it is increasing function, means that is positive from minus 1 to 1. So if I say f of x plus p is greater than 0, so p should be greater than minus 2x, and we have the values of x which is minus 1, 0 and 1. So place any value. I'm using positive 1. So p is greater than minus 2 into 1. So one possible value of p could be greater than 1. So any value, let's say that is 1. 4b says state with justification whether this is the only possible value of p. Okay. So if we have this function when it is greater than 0, and if we try for other values, we just did with 1. Now let's try with minus 1. So p is greater than minus 2 into minus 1, so p should be greater than 2. greater than 2, it is giving me more than one value. So this is the incorrect justification. P can have different possible values. P is greater than 2, or P could be 1, and it can have different values. Stationary points. Now how do we get them? Suppose we have y as equation. When we go for derivative dy by dx, that will give us the turning point has a gradient 0. Turning point at turning point dy by dx is equals to 0, which is the stationary point. So stationary point could be maximum or minimum. So when you have to find this, we equate the derivative with 0, gradient of horizontal line. Find the least value of the following functions. Okay, least value is again the stationary value, or the greatest value is the stationary value. So if we have this question, f of x is equals to x square minus 12x plus 8. So f dash x is equals to 2x minus 12. Once derivative is done, you equate that with 0. 2x is equals to 12, x is equals to 6. So we have the least value when x is 6. So we substitute x, f of 6 is equals to 6 square minus 12 into 6 plus 8. 36, and let me get a hold of calculator. Minus 72 plus 8. So 36 minus 72 plus 8 is minus 28. So least value is negative 28. Question 2 says find the greatest value of the following functions. Again, derivative and equal to 0. So let's try this one. So f of x is equals to 6 plus x into 1 minus x. So f dash x is first function into differentiation of second plus second function into differentiation of first. Simplifying minus 6 minus x plus 1 minus x. So I'm getting minus 5 minus 2x. So when we substitute 0, that is 5 by minus 2 is equal to x. So at negative 2.5, it gives the greatest value. So we put that back and see what the value of the function is. So 6 minus 2.5 into 1 minus 2.5 gives me 3.5 times 3.5. So that is 12.25 is the greatest value of the function this. Question 3 says find the coordinates of the point where the gradient is 0, dy by dx equals to 0. On the curve with the given equations, establish whether these points are local maximum points or local minimum. Now we are moving one more step. Y was equation, dy by dx was gradient, and d square y over dx square will tell us the nature of the point. Now if d square y over dx square is greater than 0, that means positive. Positive means a smiley face, that is minimum point. If d square y over dx square is less than 0, negative, negative is sad face, that means maximum point. So if we select this equation, this is y is equals to 4x square plus 6x. So dy by dx is equals to 8x plus 6. So when the gradient is 0, 8x plus 6 minus 6 by 8 is equals to x. X is equals to negative 3 by 4. I have this value of x, but I have to see if it is maximum or minimum. So I'm going for double derivative. Using this derivative again, dy by dx is equals to 8x plus 6, and d square y over dx square gives me 8 only. So in this case, I know that the derivative, double derivative, is greater than 0, which is positive, means it is local minimum. Let's try another question B. Let me clear the space. So B part, y is equals to 9 plus x minus x square. So dy by dx is equals to 9 is constant, goes away. That is 1 minus 2x. So when gradient is 0, 1 minus 2x, 2x equals 1, x is equals to 1 by 2. Now the double derivative, d square y over dx square. I'm derivating this section directly. 1 is constant, goes away, minus 2x, it is negative 2. So I can see that is negative 2 already. Double derivative is negative, so it is a maximum point. Let's try question number 6. It says find the maximum value and hence the range of values for this function. So if the function is f of x is equals to 27 minus 2x4, when we derivate it, 27 is constant, goes away. This is minus 4 2 times 8 x cube. So I am going to substitute 0 is equal to negative 8x cube. So x cube is equals to 0, x is equals to 0, cube root both sides. So it gives the turning point at x is equals to 0. So double derivative would be f double dash x, and differentiating this part again, we get minus 27 x square. 8 3 times is 24. So 24x square. Now you see, whatever the value of x is, although we know that it is 0, whatever the value of x is, when you substitute in it, you will still get a negative answer. So negative answer means that it is a maximum point. So find the maximum value. It is already a maximum point, and the maximum value is when x is 0. So when we substitute x is 0 in the given equation, maximum value is 27. Any confusion? We know that the maximum value is 27, and the question said hence find the range. We see we have a negative point, and we were already sure that it is the maximum value. So if it is the maximum value, all values should lie below this. So f of x is actually less than and equal to 27. So 7 number says x raised to power 4 plus 3x cube minus 5x square minus 3x plus 1. Find the coordinates of stationary point. So derivative equals to 0. So f dash x is equals to, derivating this equation, this is 4x cube plus 3 times is 9x square, 5 2 times is minus 10x minus 3. Once derivated, 1 is constant, that goes away. We substitute this equation equal to 0. F dash x is, I'm just copying it, 4x cube plus 9x square minus 10x minus 3. Now you substitute it equal to 0 to find the turning point. So we go for hit and trial first to see where it is 0. So I'm trying 1 first. So 4 into 1 cube plus 9 into 1 squared minus 10 into 1 minus 3, and I'm getting 0. So when x is equals to 1, I'm getting a 0. On the other hand, we need the remaining points. So when x is equals to 1, I can say x minus 1 is a factor. So I'm going for long division. This is 4x cube plus 9x square minus 10x minus 3. So x minus 1 is the first factor. To get 4x cube, I'm multiplying it with 4x square. This is 4x cube minus 1 is minus 4x square. And we change the signs and subtract them. 13x square minus 10x minus 3. To get 13x square, we multiply it with 13x. 13x square minus 13x. We again change the signs and add them. This is 3x minus 3. So plus 3, we get 3x minus 3, changing the signs, that's a 0. So this equation right here, which is 4x cube plus 9x square minus 10x minus 3, could be written as product of these two. So I'm writing this, or let's say f dash x could be written as x minus 1 into 4x square plus 13x plus 3. So we have already done the first factor. Now let's break this quadratic factor. So 4 3 times is 12 and 12 one time is 12. So let those factors be positive 12x and x. Adding these two, I'm getting 13. Multiplying these two, I'm getting 12. So x minus 1, 4x common, x plus 3 plus 1 common, x plus 3. So finally x minus 1, 4x plus 1 and x plus 3. Now I can say that dy by dx is equal to 0 when x is equal to 1, and when x is equals to negative 1 by 4, and when x is equals to negative 3. Now I have these three different points where I'm getting derivative equal to 0. So I need to find the nature. So for the nature, I'm copying this value again. That is 4, 9, minus 10 and minus 3. 4, 9, minus 10 and minus 3. That was f dash x. Now we double derivate it to find the nature. So f double dash x is equals to 4 3 times is 12x square plus 18x minus 10. Now we check them on each of these points individually. The 12x is 1, square plus 18 is 1 minus 10. So that is 12 plus 18 minus 10. I'm getting a 20. So I know when x is 1, let me just make sure we have to find the coordinates as well. Find the coordinates, yes. So let's go for the coordinates first and then we'll check the nature. So at 1, minus 4 and minus 3. This is the equation. Sorry, that is derivative. So this is the equation. I'm substituting 1 in that equation. F of 1 is equals to 1 raised to power 4 plus 3 into 1 raised to power 3 minus 5 into 1 square minus 3 into 1 plus 1. So what do we get? 1, 3, minus 5, minus 3 and 1. 1 plus 3, minus 5, minus 3 and 1. I'm getting negative 3. So one of the turning point is x1, y minus 3. Second turning point, what was the value of x? That is negative 1 by 4. So this is negative 1 by 4. I'm substituting it in calculator directly. So negative 1 by 4 raised to the power 4 plus 3 into negative 1 divided by 4. That is cube minus 5 into negative 1 by 4 squared minus 3 into negative 1 by 4 plus 1, and I'm getting 357 by 256. Negative 1 by 4, 4 plus 3 into negative 1 by 4 cube. Quickly rechecking it. Minus 1 by 4 squared. And 3 into negative 1 by 4 plus 1. Okay, that is it. I'm writing it in decimals. So negative 1 by 4 and 1.39. Okay, the third point is negative 3. So replacing all these values with negative 3. And negative 3 cube minus 5 into negative 3 squared. 3 into negative 3 plus 1, and I'm getting negative 35. So negative 3 and negative 35. So we know these three turning points. Now we have to check the nature. I've already checked the nature for the first one when I substituted 1 in the double derivative, and I got a positive answer. Positive means smiley face. So smiley face is a minimum point. Now I'm checking for negative 1 by 4. So f double dash negative 1 by 4 is equals to 12 into negative 1 by 4 squared plus 18 into negative 1 by 4 minus 10. Using calculator again. Plus 18 minus 10, and I'm getting negative 13.75. So negative means a sad face. So this is a maximum point. And the last one, f double dash of negative 3 is 12 into minus 3 squared plus 18 into minus 3 minus 10. That is positive 44, and positive means smiley face. That is a minimum point. So these are the natures, stationary points and their nature, and now they require to sketch the graph. Okay, so in order to sketch the graph, I know we have a turning point at 1, negative 1 by 4 and negative 3. So let this be 1. This is, let's say, 0, minus 1, minus 2 and minus 3. So one of the point is 1 comma minus 3, x1 or minus 3. Other point is negative 1 by 4 and 1.39. Last point is minus 3 and minus 35. So it should be very much below. Now these are the three turning points. Let me mark with a cross to highlight them. And I know this is minimum point and this is the minimum point. So it should be like this, moves up on the other end and comes down this way. So this shows a minimum curve, this shows a maximum curve, this shows a minimum curve again. Now just to be very sure where it intersects, where f of x is equals to 0, that is actually not the demand of question right at this point. So I'll remove these to avoid any sort of mistake in that, because we are not interested in answering these. So this is the sketch. Any confusion?